Hi, in the previous videos we talked about how to generate the full volume texture and also the shell geometry. Right now it is the time to bring it and make it work both Unreal and Unity. So let's start from Unreal first. So right now you can see in my content browser I already created a folder called the tutorial 034 and I put everything in this folder. So here you can see I import the volume for texture. So this is the same one I generated in the previous video. So you double click this texture, you will see the setup here. I import it as a mask, so make sure there is no sRGB. So here for the position, better position, I just use the vector displacement map. You also can use the mask BC7, not BC7. You can use the BXT1, but for better result, since that is not a color, so you can use the grayscale. The grayscale, it can save some memory. So there should be same result. You cannot see big difference between that. Okay, bring it back. But you can see this one will be bigger, like 1 megabit. But if I switch back to the grayscale, it's much smaller. So for the game, you better use the grayscale. Yeah, we can save like that. And here is the shader I made for this effect. So since I changed the texture, the shader will compile here. So I export the geometry and import the base geometry and also the shell mesh. So you can see I have some example here. This is the base one, the base geometry, and also I found the texture. I put the texture as original texture for the rubber toy, and also I have a different example for the different layers. They have a 16 layer for this is a 32 layer, this is a 64 and 8. I use a different shader between them, but also it's the same. It's just a little bit different inside the shader. I did some tweak, make some gravity result, and add some curve. So these three, 32, 64, and 8 use the same material. This is a simplified one. What I use is I add some wind effect and the gravity curve. So here you can clearly see the fur is moving. So that is a fake wind effect. I don't want to make the materials too complicated. So here is my shader. Let's take a look at what is inside the material. There are 5 common sections here. The first one is the shell layers. I imported the vertex color from geometry. We baked the index information in the alpha channel. So import this information to the next section for the mapping volume texture. They convert the index to the correct UV, and then we can get the sub UV remapped the subsection what we want. Then we output this to the opacity mask. Here we also use the index information to extend the floor layer. So make the floor longer or shorter. So here is pretty simple, just multiply the distance what you want, then multiply to the normal in the workspace. And then we have the wind jitter. In that section, I simulated the wind effect on the floor. That is a simple simulation. To do that, you need to do the cross product of the wind direction and normal. So cross product create a new vector which net integrate to the import the vector. So that means after this cross product, it will give you the new vector which net integrate to the normal direction and also net integrate to the wind direction. And we use that like B normal to do the another cross product with the normal direction, then you will get the wind direction. Then we normalize that, multiply to the time, and you can multiply any number to make the wind frequency. The number is higher, they will move faster, and then we do the cosine to create the wave from -1 to 1. Then we multiply to the wind intensity. Then we multiply to the index. So to make 4 normal, and you want to have some anisotropic effect, to do so you need recalculate the 4 normal. So here what I'm doing is, first thing I needed to know the direction of the camera. They call the camera vector. So to do that, you need to subtract the absolute world position to camera position. Then you get the camera vector on this pixel. So to do the normalize, then cross product to the normalized normal world space normal. That value should be normalized already. Then after cross product, like we mentioned before, you will generate a new vector which 90 degree to the wheel vector, the camera direction, and also 90 degree to the normal vector, the direction. So it's kind of like B normal direction, B normal vector. Then you do another cross product with the normal, then you will get the new normal vector for the fur. Then you output that to the normal. In that case, you select the material and search the normal, turn off the tangent space normal, because you regenerate the normal, that normal is based on the world space. So when you turn off the tangent space normal, they will use the world space normal directly. Here I also added the albedo texture and set up the roughness, just like a regular setup in the material. Here I import the ambient occlusion. So the reason why doing the ambient occlusion is it should have the fur should have the self shadow, because the density of fur will occlude the lighting. So since the occluded lighting, so close to the root, it should be more darker. So to simulate that, since we probably don't have enough precision to generate the SSAO in your game, so what you can do is just to reuse the index what we baked. That is really useful information. So they give you not only the index of layer, but also you can use for a lot of different stuff. They also give you the information of how deep the layer it is, so how deep the fur it is. So more darker, it should be more close to the root. The 0 value is the root, the 1 is tip, so we can use that directly. I did some power calculation here to make them more nature, not linear. Power 2 in my case is pretty good. If you don't, you want more, you can put a 3. Then I use a linear interpolator with a AO parameter. So when this value higher, we will use more from the index information. So the root will be darker. If less 0, they will use the default value. I set up 1, which no AO. So I output this to the ambient occlusion and also multiply to the albedo, because I want it work on the direct light. If you only output this to the ambient occlusion, when the light on it, you will not see that effect. But in this case, I want to see everywhere, so I output to specular and also multiply to albedo. So make it fully occluded, so no one can make the root brighter. Probably you can set up some threshold here, not 100% to affect the albedo, because probably you want the direct light can make it brighter, so you can tweak here how many percentage you want to affect to the albedo and also the specular. So my case is 100% if I turn on the AO to the 100%. Now let's talk about how to do the same flow effect in the Unity. I open the Unity. I use the 2020.1. So the first thing we need to do is import the texture and the geometry, the base geometry, also the floor shell mesh into the scene. I create a gem like that. I put the mesh in the mesh folder, texture in the TX folder, and also create a material shader in the material folder. So the mesh, when I import it, they have a base one, the base mesh geometry, and also import the two different density. One is 8 shell layer, another is high density layer one. For the long floor, 64 layers. So when you import it, you need to make sure you import the vertex color, and then import the texture here, the volume for volume texture. Import as grayscale, so it's only simple channel. They show the right channel, the 4 channel, and I set up it's only in the right channel and 2K, and use R8 format. And also import the albedo texture and speck texture for the rubber toy. Then I created the material. So the material have two shader. One is base one. I just used base one for the base layer, and also I created a floor shader. Here I call the shader base one. So you can see I use the S base, S underscore base, this one, the shader, and there is some parameter. You can tint the color, use any color you want for the floor, and just multiply color on the top of the albedo, and you can type in the UV for the albedo texture and control the smoothness, metallic, alpha cutoff. That actually for the alpha test. Let's make it closer. So if you have a less number, the floor will feel more sync. So put 0.1 or 0.03. Yeah, I think that's better one. And also there is a floor mask. Use the floor volume texture. And also have the distance, how far it is for the 8 layer, not too far, otherwise it looks not like 4. It's split it. So I also added the AO for the 4, like I introduced in Unreal side. So the Unity have the similar result. So they added some dark on the root to simulate the occlusion, and also added a gravity drop. Yeah, that is too much, so you need to be careful. A little bit. And this tiling X tail Y is defined the same thing like in the Unreal, the grid X and the grid Y, to tell the shader how many section you have in this volume texture. So let's take a look the shader itself. The shader is pretty simple. If you're familiar on Unity, you will know how to write the base, the surface material shader. This is just the basics surface material So first thing is you define the properties, how many parameters you want to change, control. This is what you see here in the UI. It automatically generates the UI. You just need to define what kind of a data it is. You give the name and the variable name in the shader and the label name you want to show here, and also the default number, and the type is the color, this is 2D texture, and this range thing is more for the float. Yep, this is int for the x and y. Then you make the shader in the alpha test mode. And we use target 3 point model 3. So then you define two texture you want to put in the shader, main texture and the floor texture. So main texture is more for albedo. I know I have a specular one. I didn't connect. I didn't create there. You also can create other texture like roughness, metallic, any texture you want, and you created the structure input. The structure input actually is the data input to the your pixel shader part, this part. So what I want to put in is a UV main texture. It will give you the first UV and the UV2 for texture. So it will give you second UV, and also define color here is the vertex color. So this is the import that will transfer the data from vertex shader to the pixel shader. Also, I need some variable, so I defined the half float for ghostness, metallic, and also for the tile x, tile y, also for the full gravity drop. So all of this I already put here. So here it just defined what type data it is. Also, create the function to sample the UV. It's a similar function like what I did inside Unreal. In the sub UV function, you need to import the current UV coordinate you want to use, and you need to put it in the section, maximum section on the X and on the Y. In this case, 8x8, and also which index you want to access. So here it transfer the convert the index to the XY position, and then based on that the scale the UV to the correct section part, and offset to make it just fill 0 to 1 position. So basically doing the same thing as in the Unreal. So in the texture you will see what it's doing is they get the based on index to find which section, for example this one you wanted to use, and scale that one to the size like 0 to 1 size, and also offset it to fill from 0 to 1 space. So when you access, put in UV there, put the index there, when you access it from 0 to 1, it will always sample, for example, for this texture from there to here. So they only give you this section. You will not access other section. So basically, this is what a function return. So here, when I call that function here, then I import the current texture coordinate. The one meaning is second UV, and also put a tile X, tile Y, what I import. Then I get the vertex color. W is the alpha channel, is XYZ, and W, XYZ is RGB, and W is alpha. So this is alpha channel, the color alpha channel, and multiply the tiny x, tiny y is the same like in Unreal. So it just because this when import is 0 to 1, the range is from 0 to 1. So this is 8x8, so the 64 layer actually. So it just converts 0 to 1 to 0 to the 64. Then jump to the surface shader, pixel shader part, and the new UV The second UV, what I overwrite here, will transfer to the surface shader. So here the UV2 for FX is calculated the UV only for the section you selected, and I get result. So, but here you can see a sample twice. The first one I sample is called mask, and I sample twice. The reason why it's sample twice is I want more density. This texture is not exactly the same one I use for the in the Unreal. Unreal is a more density one, but for this, I just want to show you there are another way to make the for more density, but a little bit cost, because you need a look up texture twice. So the same texture, they sample them, but it just offset a little bit. Imagine this one section will be filled on the full UV space 0 to 1. So 0.5 mean I want offset half size of this section. So then the 4 will not override. So it will just like you duplicate this texture and offset it, make more 4 density there. So here the thing is I use a fraction. The reason why I use a fraction, because this is calculated UV is not in the real UV space. So even you set up this texture to use whatever you use, clamp or use repeat, will not work, because it's calculated UV. This UV is modified it inside of the sub UV function. So to make the tiling, I use a fraction. So when I add the half size of this section is over the 1, they will back to, for example, if 0.3 and add on it will be 1.3, they will back to the 0.3. So let's really have a fraction here. Then you have a 2 mask. Second one is offset, so I use the lerp to mix them together, and also add the 4AO here. So basically just like that. The result is pretty simple. If we have enough layer, you can make longer for effect. But like I said from first video, that technique actually only good for the short fur. It's not only because performance wise, but also the result, the control. This cannot be you cannot add any simulation, physical simulation or animation on the top. It's all shader stuff. So when you add anything like wind, even you simulate like impact, you probably can do that in Unreal or also in the Unity. It's everything in the shader. So there are no any physical calculation based on the bone stuff, based on the CPU, because bone most time calculated in the CPU side. So if you have a long fur, very long one you want to use, you probably need to use another solution, which like hair system, the hair clip. Okay, I hope you enjoyed this video. See you next time.